Hello everyone and welcome to numerical series of electrical machine. This question is frequently asked in the boarding exam of Pokhara University. And today our numerical problem is an electromagnetic. First problem is an electromagnetic magnet as shown has a cross-sectional area of 12 centimeters and mean length of iron path is 50 centimeter. It is excited by two coil each having 400 turns. When the coil is 1 ampere, the resulting flux density gives a relative permeability of 1300. Calculate reluctance of iron path of magnetic circuit, reluctance of air gap, the total reluctance and total flux and the flux density in the air gap, neglecting the leakage and fringes. This is the circuit diagram. This is the number of turns equal to 400, 1 ampere current, and this is the mean length 50 centimeter, 4 centimeter air gap, and area is 12 centimeter square. First of all, write all the given data, and the given data is area equal to 12 centimeter, so 12 into 10 to the power minus 4 meter, and length of iron equal to 30 centimeter, 50 centimeter, so 50 into 10 to the power minus 2 meter. Convert this into the meter. So and number of turns equal to 400, I equal to 1 ampere, mu r equal to relative permeability 1300, length of air gap 0.4 centimeter, and this is the mean length of iron. So this is the mean length, not the length of iron. So length of iron equal to LT minus total length minus length of air gap, that is 0.496 meter. And we know reluctance equal to L upon mu naught mu r A. So reluctance of iron equal to Li upon mu naught mu r A. Put the value of mu naught mu r A Li, we can get the reluctance of iron. And next one, reluctance of air gap, at Lg mu naught mu r A. For mu r equal to 1 for air gap. In the air gap, relative permeability equal to 1. So put all these value, you can get the length of reluctance of air gap. Total reluctance equal to Si plus Sc. Adding Si plus Sg, we can get total reluctance. And MMF equal to 5 into reluctance, so 2 into Ni. Reluctance of iron plus reluctance of air gap. MMF iron plus MMF air gap equal to 5 into total St. So 2 into Ni upon St. Put all the value, we can get the value of 5. And the flux density in air gap is flux equal to B equal to 5 Ia, and the flux density is B, so 0.275 into 10 to the minus 3 upon 12 into 10 to the power minus 4, then you can get 0.229 Tesla or Weber per meter square. And the next problem is a ring shaped magnetic core shown in the figure. Shown in the figure is made up of material having a relative permeability of 1000. The flux density in the smallest area of cross section is 2 Tesla. If the current through the coil is not to exceed 1.5 ampere, compute the number of turns in the coil. We have to find the value of N. And this is all length given. Length L3, area A3, A1, and L2, A2, L1, everything. The material are of the different length and different cross section area, but their flux are same. Okay, then B given mu r equal to 1000, B 3 equal to 2t, and I equal to 1.5 ampere, and N equal to what? L1 10 centimeter, A1 4 centimeter square, L2 15, A2 3 centimeter square, L3 20, and A3 2 centimeter square. Therefore B3 equal to 5 upon A3. Then we can get the value of 5. MMF equal to H1 L1 plus H2 L2 plus H3 L3. Then in the place of H1 we can write B1 upon mu naught UR. Similarly, place of H2 B2 upon mu naught mu R. In place of H3 B3 upon mu naught mu R. So in place of B we can write 5 upon A1. Similarly 5 upon A2. Similarly 5 upon A3. Then you can get N equal to 5 upon I mu naught mu R L1 upon A1 plus L2 upon A2 plus L3 upon A3. Put all the value. We can get the value of N. And the value of N is 2371.36. That is 372 tons. And the next problem is a magnetic core in the form of closed circular ring has a mean length of 30 centimeter and a cross sectional area of 1 centimeter square. The relative permeability of the core material is 2400. What are the current will be what DC current will be needed in the coil of 2000 tons uniformly wounded around the ring to create a flux of 0.2 milliweber in the core if an air gap of 1 mm is cut through the core perpendicular to the direction of flux. What current will be needed to maintain the same direction, same flux in the air gap? And the mean length equal to 30 centimeter, area equal to 1 centimeter, mu r equal to 2400, and we have to find the DC current. N equal to 2000 tons, phi equal to 0.2 milliweber, length of air gap equal to 1 mm without air gap, then mm PHI. So DC current equal to 198.94. Put here the value of everything, we can get the value of DC current with air gap. Ni equal to 5 upon mu naught mu r LT minus LG. This is the length of air gap. Sorry, this is the length of iron LT minus LG, and this is air gap. Then put all this value, we can get the value of, put the value of 5 mu naught mu r A LT LG. Then we can get the value of I. Value of I is 0.89. Similarly, the next problem is an iron ring of mean circumference equal to 18 centimeter. It is uniformly wounded with 500 tons of the wire. When a current of 1 ampere pass through the coil, a flux density 1.1 Tesla is produced in the iron. Calculate the relative permeability of the core under this condition. So Li equal to Lt 80 centimeter, N equal to 500, I equal to 1 ampere, B equal to 1.1 Tesla, and mu r equal to what? We have to find the value of mu r, and mu naught equal to 4 pi into 10 power minus 7 Henry per meter, and we know Ni equal to Li Hi. So Ni equal to B, value of H I, you can put the B upon mu into Li. So Ni equal to B mu naught mu r Li. Put all the value, we can get the value of mu r, and the value of mu r is 1400. This is the value of relative permeability. And next problem is a cast steel ring of mean diameter 50 centimeter having a circular cross section of 5 centimeter square is uniformly wounded with the 500 tons. Determine the current required to establish a flux of 5.5 into 10 to the power minus 4 Weber with no air gap and with a radial air gap of 1.5 mm. The magnetizing core for the cast steel is given by, this is flux density, and this is the value of H. 0.2 175, 0.4 300, similarly 1.2 1250, and mean diameter 50 centimeter, so circumference equal to 2 pi r. So 2 into, in the value of pi 2 r, we can write pi d. So the value of d is 50 into 10 to the power minus 2. Area 5 centimeter square, tons 500, and value of 5.5, LG 1.5 mm with no air gap, LT equal to LG. So MMF equal to HILI, NI equal to HILT. So put the value of HILT, we can get 3.927, and with air gap Li equal to LT minus LG, that is 1.568, and then B equal to 5 upon A, that is value of 5.5 into 10 to the power minus 4 into 5 into 10 to the power minus, when you can get 1.1 Tesla. And the curve is, this is the value of B, and this is the value of H, and we have find B equal to 1.1. So plotting this curve, we can get this value 1.1 is nearly equal to here. value of pH is here.